So glad you all able to join us here for this presentation here. So this is going to be about a project. This was a multi-year project that we worked on for the Kentucky Transportation Cabinet about optimizing snow and ice routes. And I'm going to kind of walk you through some of the history of the snow and ice program, just a little bit with the Kentucky Transportation Cabinet, show you how we put this together, show you a couple of different options for if any of you are involved in snow and ice route planning, show you a couple of options for things you could possibly do for your own locality there. And then show you some of the results of the project, some of the successes we had, and the academic successes and also the implementation successes for the cabinet. And I'd just throw out, it's going to be a lot of me talking here. So if any of you all have any questions or comments or anything, please do not hesitate to interrupt me. You won't hurt my feelings at all. I'd be glad to have this more interactive as much as possible. So please, by all means, chime in whenever you see the opportunity. Okay. So the Kentucky Transportation Cabinet Snow and Ice Program, and these numbers are a little bit older, but it typically expends between $40 and $80 million a year on the program. So that 40 to 80 million, it depends obviously on how severe the winter is, how much snow we get, how much ice we get, and how many different events there are. A really bad winter can definitely top over 100 million, and we've had a couple of those in the past. So the cabinet is responsible for more than 63,000 lane miles of roads across 120 counties in the Commonwealth. So in some states, the state controls all the roads. Most states, that's not the case. We're kind of, in the middle in that regard. So the routes that the state uses to treat the snow and ice are largely county-based. So each county has a salt barn. Some counties have more than one, but most of them just have one. And then they have a designated number of trucks and truck operators that operate, refill at those salt barns. The trucks are, usually based at the barns as well, and then go out from there to treat all the roads. And then for each of the roads, they have a prioritized system for identifying which roads are the most important, which ones need to be treated the most and the most often. And those are generally referred to as A, B, and C routes, where A routes are the most critical and B and C are less and less critical. Obviously, interstates and parkways receive the highest priority. Those are technically A routes, but they're like a special kind of A route where, that's the highest volume of traffic, the highest speed. So you got to make sure those are as safe as possible. And then the last thing on the program, I'd say the state uses both state trucks. So each county owns a fleet of trucks that they use for snow and ice and other things as well, maintenance, but they use for snow and ice program. But many counties also contract routes out, especially the urban counties. There's just so many. They don't have enough operators in the county to run that many routes. So a lot of them use contract routes, which can be pretty expensive when you start adding them all up. And I'll go into all that some more as we get into this. Okay, so the fleet in each county has 4 or more trucks. I think some have as many as 20, but most of them I would say are probably in the 4 to 8 range. And then around the state, 850 trucks, state trucks, and it's these things. Some trucks go offline, come online, so don't quote me on that number, but it's about 850 statewide. And then the contract trucks, they're typically used for interstates and parkways. So counties that have a lot of lane miles of interstates and parkways, they will usually contract those out. And the reason they use those for contract trucks is the lanes are really wide. So the contract trucks typically have very wide plows on them. So it makes sense to put those trucks on there. And also they're pretty simple and straightforward. It's treat this section of I-65 between this small point and this small point. There aren't a whole lot of turns and different things that they need to consider. So it's very easy to communicate, very easy to monitor their progress. And then overall, I think at the outset of this project, the state used about, somewhere around 400 contract trucks statewide. And again, those are concentrated in really concentrated in districts 5, 6, and 7. That would be Louisville, Northern Kentucky, and Lexington, which is where the highest population density is. And then all the trucks, whether they're state trucks or contract trucks, they all go to the county salt hauler to refill on salt. And we generally set that at about 15-minute reload time, but that can be more or less depending on how busy they are. Okay, so the cabinet has a priority system that they have, a policy that they have developed for how to treat the roads. And I mentioned the A, B, and C priority routes and interstates. So according to the Transportation Cabinet policy, all lanes of all interstates and parkways should be treated during a routine winter storm with a goal of a 1-hour turnaround. That means as long as the roads still need work, as long as they're not clear, then the goal is to have a truck, hitting that every lane every hour until they are open, until they are clear. You can imagine that's a lot of work for every lane, every interstate, every parkway, all the ramps and everything. All other A priority routes, so you can imagine these being like US 60 or major routes like that carry a lot of traffic. The goal is every 2 hours, have a truck on those every 2 hours. And then for the B routes, these are your sort of medium volume traffic roads. It's every 4 hours. And then the C routes, when we started this, the policy said every 8 hours. They've actually amended the policy now, and they say, basically once a day. And many of the counties, if there's a snowstorm at night, then they try to concentrate their trucks on the A's and B routes and leave the C's for the morning. And some of this varies by county, but that's by and large how they do it. So this is an example of each county has a snow and ice book that they submit to the district, so that the district officials will, kind of monitor the program, track everything. But the counties are largely responsible for deploying the trucks. So this is an example from Anderson County here. So this is Lawrenceburg in here, and you see, it's kind of hard to see. I think the county routes come along like that. So the different colors represent different trucks that they send out. You can see the color coding here, the different trucks. And then you see this is truck 6 and B. That means if it's dotted like that it's a B route. So you can see this up here. These are B routes that truck 6 takes on. They're actually kind of hard to distinguish between B's and C's in this symbology. But you see here's truck 5 does these roads down here. And truck 4, the green one, comes out here, does these. Truck 3, the yellow one, so forth. And then over here they sum up everything tabularly. So you see this county uses 6 contractor trucks. They're not actually represented on the map, but they use the contract trucks up primarily for, this is the Bluegrass Parkway coming along here. They've got a lot of Bluegrass Parkway miles they got to treat. And I think they also put some of those contract trucks on US 127, which goes north from Frankfort through Lawrenceburg and then south towards Harrodsburg and Danville. And then they've got 5 salt spreaders, which is funny. It says 5, but there's 6 listed over here. I'm not sure why that is, but that's okay. Okay, so that's the background on what KYTC does. So our goal was, we know by and large, the routes that the Transportation Cabinet had been using, it was largely paper-based. It was something they'd been doing for many years. There's a lot of built-in knowledge in how those routes were put together, but nonetheless, we believe with GIS, geographic information systems, tools, and other types of analytical tools, that some types of optimizations could be done to improve the efficiency of the routes. And improving the efficiency of the routes is important because A, it would improve mobility, right? You would have better treatment of the roads. You would have less salt or less snow and ice on the roads. You obviously make the roads safer if people aren't driving on snowy, icy conditions. The conditions are much better. And from the cabinet's perspective, it's also going to save time and money. every time you have to call out a contract truck, you're not only paying for the contract, you're also paying for the labor. A lot of times there's overtime incurred when you're sending people out to treat these routes because it's a 24-hour job. And obviously, anytime you're dropping salt on the roads, that salt, it gets expensive over time. A big portion of that 40 to $80 million total that I mentioned at the beginning was the salt itself. So anytime you can improve the efficiency of the way you treat the routes, you're going to save a lot of money as well. So that was the goal. That's what we set out to do. We didn't have a developed methodology when we began. Part of it, we are a research center, so that's part of what we do is we try to identify and innovate and identify new solutions or improve on existing solutions. So what we sought to do to begin with, I don't know if any of you are familiar with GIS. Esri is the company that makes ArcGIS, and they have it's a mapping-based spatial analyst tool set. And one of the things they have is called Network Analyst, and within that they have what's called a vehicle routing problem. And so what this means is it's a network-based spatial analysis tools for solving complex routing problems. Okay, it's a mouthful. So basically what that means is you think about a company, say you're UPS, right? And you've got a bunch of deliveries that need to be made to a bunch of different addresses, and you've got time constraints on when you need those deliveries made, and you've got a set number of trucks that can handle the capacity of the orders. And what's the best way to deploy that fleet? And so what these tools do that Esri has developed, they help you start to understand, you supply the parameters, you tell how many trucks you have, where the orders are, where they need to go to deliver the packages, so to speak. And then it will start to give you solutions on the best way to do that. And so we decided, well, what if we treated snow and ice like it's a delivery problem? Where in this case, instead of delivering packages to people's front door, what we're going to do is we're going to be delivering salt to the roads. We want to know, is this a possible application of this problem? Is it useful? What do we need to know to make it work, and how good would the results be if we tried it? So I say here it's an iterative process, and basically what that means is you can't just put even if you just identify the parameters and put it in, the initial results are going to be messy. They're not going to be great. You're going to have to do work with it. You're going to have to change, tweak, alter, keep bringing in new ideas, and keep perfecting the process until you get something that's actually useful. And then the bottom one here, the routing issues, and we'll go into some more detail in this one. Are we looking for the most efficient routes, or are we looking for the most realistic / efficient routes? And so what I mean by that was when we were developing this process, and we had people from the cabinet on our study advisory committee, we had actual truck drivers on the committee as well, because we wanted some people who deal with this firsthand. What kind of insights can they bring to our research? And we quickly learned that the most efficient routes is not necessarily the best solution. And so what that means is it gets really complicated when you're looking at, remember that map I showed you of Anderson County and all those roads? That was a pretty simple map where you had this truck treating these roads and these truck treating these roads. If you add in another layer, if you add in time to that, which is what we were trying to do with this research, then it becomes really complicated, because remember, those A routes need to be treated every 2 hours, and those B routes every 4 hours. And so if you imagine you've got an 8-hour time window, this is one shift for your workers to go out and treat roads. They need to be hitting those A routes every 2 hours. So they're going to be hitting them 4 times over those 8 hours. Now, when we just punch this into the computer and say solve, it may send a different truck each time down those A routes. It may send one truck the first time down US 127 and a different truck the next time. And this starts getting, maybe technically that's the most efficient way to do it, but in reality, that's not the most efficient way, or that's not the most effective way to do it, because it just incurs too much confusion. So that was another thing we had to work through as we worked on this process. Okay, so some of the factors that we did include. So these are all the things we got to think about when we're trying to come up with a solution for what is the best way to solve the routes. So obviously we got to think about the route priority. I've talked about that a couple of times, the interstates, the A routes and the B routes and the C routes. And like I mentioned, we decided early on, we wanted to think about this over an 8-hour time period. That way you're getting a more realistic snapshot of what it's like for the truck drivers as they go out and work on these. So another thing you got to consider is the salt capacity of the trucks. Because if you're working over an 8-hour time window, it's highly unlikely that you're going to have enough salt in your truck to work that whole time. You're going to have to go back and refill. And different trucks have different salt capacities. We talk about, you'll hear me mention tandem trucks. Those are the largest trucks they have out there. They carry, what is it, 24,000, I believe, somewhere around there. And then you've got single axle trucks that carry around 16,000. We've also got smaller trucks. We've got mini tandems. We've got flatbeds. There's several different types, and they all have different salt capacities. So you got to factor that in. So I should have mentioned this too. When we're talking about optimization, if you think about it like this, you have to deliver salt to each of those road segments based on their priority, period, right? That salt has to be delivered. So you can't minimize the time it takes to actually drop the salt on the roads. That's going to be constant no matter what the solution is. But what you can try to minimize is what we call the deadhead time, the time between when they're not treating the roads, when they're driving from point A to point B to go from the salt barn to the road to deliver salt. The deadhead time is what you want to try to minimize as much as possible. And so that's where salt capacity of the trucks becomes really critical. The last thing we want to do is have the route set up to where, the truck is on the very perimeter of the county. It's however many miles, 50 miles away from the salt barn, and that's when it runs out of salt. Because then it has to drive all the way back to the salt barn, not doing anything, just to pick up more salt. So that would be obviously very inefficient. So that's what we're trying to minimize as much as possible. Okay, so the next one here, the location of the salt storage facilities. In most counties, I would say those are pretty centrally located in the county, which is a good thing from a efficiency standpoint. You got to think about the plow widths on the trucks and the lane widths. So you don't want to send a truck with an 11-foot plow down a road with 7-foot lanes, right? That might be a problem. You might have running some cars off the road, knocking over some mailboxes. So that's one thing we got to restrict which roads we can send the trucks down based on their plow widths. Another thing to factor in is, a lot of roads are not just two lanes. They might be 3 lanes, 4 lanes, or more. So you got to factor that in. If it's a 6-lane highway, do you want one truck getting all 6 of those lanes? Do you want to have 2 trucks splitting it up, 3 trucks, or how to do that? Another one, the truck travel speed. Trucks drive slower than your average car on the road, right? Especially in the snow. And there's good reason for that. Obviously, it's a safety consideration, especially you get in the mountains of Eastern Kentucky, you get those windy roads. You don't want trucks going around snowy, icy roads going too fast. They might slide right off. So we set the truck speeds based off of the posted speed limit. So what we did, and this was in conversation with the truck drivers and what they thought would be a good way to understand this. So if this posted speed limit was 40 miles an hour or less, then we would set the truck speed to 15 miles an hour. And that takes into account, you're going to be going a little bit slower around curves. You're going to be going a little bit slower uphill. You're going to have intersections where you might have to stop. But over the course of the 8 hours where you're working, we're going to say about 15 miles per hour. For all other roads, if the speed limit's greater than 40, so these are your, U.S. highways, your interstates, even on interstates where the posted speed limit is 70 miles per hour, we're putting the trucks at 30 miles per hour, which is a lot lower. And the reason we do that is because that's actually the speed that they want the trucks to be going at. When you start getting much over 30 miles per hour and you're dropping salt on the roads, what you're going to find is significant portion of that salt, if you're going say 45 miles an hour and you're dropping salt, a significant portion of it's going to bounce right off the road and go off the shoulder into the ditch or whatever. And you're effectively wasting salt if you do that. So 30 miles per hour is the most effective speed for putting salt down. So that's what we would settle at there.
Hey, Ben, you have a question from Tim. He says, has there ever been a plan to use feeder trucks to transport salt to the trucks instead of going back to the salt farm? Have you heard of that?
I've not heard of that. No, I guess that could be possible, especially for the contract trucks. I would say for the most part, because we have 120 counties in the state, none of our counties are all that large. So it's not been too big of a problem to have the trucks come back to the facility when they need to refill. I suppose for some of the larger counties that might come more into play.
Well, and I guess some counties have more than one salt barn, and I could see this being something maybe up north would try.
Yeah. So Jefferson County has 2 salt barns. Pike County actually has 3 because it's the largest county and it's also a mountainous county, which makes getting around pretty difficult there. I think Floyd County, which is right next door to Pike County, has 2. Off the top of my head, I can't think of any other county. I think there's one other in the mountains that has 2, but I can't remember off the top of my head which one it is.
I think Fayette County, the county itself, not the state. I thought they built a second one as well.
If they did, it's been, I think we worked with District 7 maybe in 2015, 2016. So has it been since then that they built?
No, I think the county itself did.
Oh, okay.
The district office, the county, yeah.
And that was actually one thing we identified was Fayette County, I-75 as you're going towards Madison County, down that little area down there was sort of a Bermuda Triangle, so to speak, where it was very difficult for either Fayette County or Madison County to get there, on time. So, to get those interstates every hour like the policy states. So that was one place where we said if you were going to put just a salt barn just for this purpose, that would be a good place for it. Another thing we need to consider is just simplifying the routes as much as possible. I kind of alluded to that earlier about not having multiple trucks go on the same road because it gets just too complicated. Especially for the contract trucks, you can't hand a contractor who's never done this before, who has a new driver, and just say, here's a 50-step set of directions, now go to work. That's not going to be a very good way to do it. They're just going to there's too many concerns with safety and even for the state truck drivers, they prefer to know their routes. They go out there, they practice their routes, they get to know everything about those roads. They know where the dips are, they know where the culverts are, the embankments are. They know exactly how to do them. So they want to be experts when they go out there, and they don't want it to have to be changing and just crazy. The kind of what I alluded there too, they have the input from drivers treating the routes. So I've talked about that a couple of times. We had truck drivers on our committee because we wanted their perspective. They know more about this than we do. We know how to be efficient, but they know how to actually treat the routes. So we need their knowledge when we're doing this. Otherwise, we're just going to be delivering, meaningless results for them. And then the last one, it's a joke, right? It's proximity to local politicians' homes. We put that in there, and usually we get a chuckle from the truck drivers, but that's the joke. But in actuality, they do mention to us that, hey, we get calls from citizens saying, hey, there's certain citizens, they get calls from saying, hey, my road's not clear. Hey, my road's not safe. Hey, my road's not clear. And it's just when you're getting the calls over and over, then they tend to give those roads more attention. And that's just the way it is. Okay, so I'll go through, this is kind of the academic side of it a little bit. I'll go through this quickly. I mentioned network analysts. The I mentioned how using an entire fleet, it can calculate drive times, it can locate facilities and solve the other network related problems. In the vehicle routing problem, this is the specific thing we use for deploying a fleet to deliver the salt to the roads. The goal is to best service the order and minimize the overall operating cost for the fleet of vehicles. And you can imagine UPS and FedEx, these are the exact type of things that they do when they're delivering orders to people's houses. And then the vehicle routing problem solver, it can solve more specific problems because numerous options are available, such as matching vehicle capacities with order quantities. You can factor in breaks for drivers. You can pair orders so that they're being serviced on the same route. So if you want to say, I want all of these to be paired together so that no matter what the most efficient is, I want this truck, if it's getting this one, it needs to get these others as well. So there's a lot of customization available in the program. Okay, and this was some of the detailed GIS work we had to do up front to make it work. The lanes factor, this was something that took a lot of work from us up front because I mentioned earlier some roads are 2 lanes, 3 lanes, 4 lanes, 5 lanes or more or whatever. And we have to account for all of that when we're deploying the trucks. So a lot of GIS work went in there to make that work. And then some are divided highways, some are one-way, some are ramps. The divided highways is important here because many of the trucks, if it's a 2-lane undivided road and you're dropping salt, the salt spreader actually can be on the left back side of the truck. So it's actually dropping salt on the center line, which means it's hitting both lanes, the to and the from lane that you're traveling down. So that's very efficient. If it's a divided highway, obviously that doesn't work. You have to drop salt both ways when you're doing it. So for the program, then we set up the snow and ice treatment as a delivery and an optimization delivery of the salt. And the way we set it up to make it as simple as possible, we put midpoints at all of the road segments. And we offset the points to the right of the driving direction. And what the points mean is these are deliveries of salt. So if you imagine this is like the address where UPS is delivering the package. In this case, it's delivering salt to this point on the road. And the volume corresponds to the length of the road segment. So if you've got a, say, 1.5 mile segment, there's going to be 1 point to the right of the midpoint of that road. And the truck has to get to that midpoint to drop that salt. And then the quantity accounts for the salt for the entire road segment. And then the second thing we do is we set it up so the truck can't turn around in the middle of the road. The truck can't turn around until it gets to an intersection. So it drops the salt at that midpoint and then it has to keep driving. And that's just a way of tricking the software, so to speak, to make it work. And then we put in the truck capacities, the salt capacities, how much they can deliver salt before they have to refill. And then we set up time windows to count for those route priorities so that the A routes are being met on time, the B routes are met on time, and the C routes. So kind of what it looks like here, this is Clark and Montgomery County, and you see all the little dots everywhere. And it's kind of like Pac-Man going around to gobble up all those dots and deliver salt. And hopefully there aren't any ghosts out there chasing it, but if there are, so be it. Okay, I think before I go any further, I'm going to give a little demo of how this software works. I don't know if any of you all have any experience with ArcGIS or have any, if you run a snow and ice program for any real localities, this might be of interest to you just to see how this works. So what I've set up here, this is an ArcMap. This is Jessamine County here. You can kind of see the county outlines, and then in red are the roads in Jessamine County. The solid lines here, you can see Jessamine A, those are the A routes. And then the sort of the lighter red ones with the closer dots, those are the B routes going around. And then the ones that might be hard for you to see, but these out here, these are the C routes. Okay. So
And these are the state routes, correct?
Yes, these are the state roads. So the roads that are maintained by the state, yeah. Okay. Let's say new vehicle routing problem. Okay, so first thing I need to do, and a lot of the work I've already done up front. Obviously, it would take forever if we're starting from scratch, but I'm just giving a demo here. So I showed you earlier the points for those other counties. We're just going to use the Jessamine County points. These are the salt delivery points. So let's select those. Okay, so you see these are the roads that Jessamine County treats, and you can see some of them go a little bit beyond the county line. A lot of these counties have, little agreements with one another. It kind of makes sense if you go here, and we'll make up for it by going there, things like that. So we're going to load all of those points here into the orders field. Well, there we go. Move a little slower here. Okay, so there's 291 of these in Jessamine County that we need to address. Okay, the next thing is depots. This means where's the salt barn? And you can see if I click on this one, right here, this red dot here, that's where the salt barn in Jessamine County is. So that's going to load that into ArcMap. Okay, so you see you got that in there now, Jessamine County. Okay, now some of the customization I've developed for this one. I'm getting these things down here, specialties. What I do for these is I use the specialties. This means if you want to say certain trucks can only deliver certain types of packages. Well, what I'm going to do for this is I want certain trucks to only be treating certain roads, right? I don't want the big tandem trucks going down a windy a windy 7-lane road or anything like that. So the way I've kind of set it up where I'm going to add to this. I've got, I'm doing an A1. So these are the A, B, and C priorities, but I'm going to do an A1 and an A. And I'll show you why here in just a second. Okay, there we go. Got my caps lock thing on. Now we got it. Okay, now I remember from doing this county before, Jessamine County has 4 trucks. They have 2 tandem trucks and they have 2 single axle. Now this road right here is the major road through Jessamine County, right? We got Lexington to the north, and we got it going down towards, what is it? Garrett County there. I can't remember what else is past that. But this is the major lane. This is the road. If you're going to put tandems out there, you definitely want tandems getting this road. So we want to account for that. So I'm going to add my trucks here. I'm going to say this one is tandem 1. It starts at Jessamine County, it ends in Jessamine County. We'll put its capacity at 24,000. That'll care about that. Then you get to specialties. Here's where I only want that tandem route. I want it definitely doing the A1s, and I'm going to say it can also do A routes. I'll let you do B routes too. I just don't want it on those windy C routes. That would get too crazy. Copy. I've got a second tandem, same name or same type, same parameters. And then I've got 2 single axle trucks. They're a little bit smaller. And I don't want these doing the A1s, I want them doing everything else. Okay, now for some reason you have to specify if you want them to allow them to refill their trucks, which obviously I do, so I have to add those too. Where is it? Okay. No, it's this one, sorry. Whoa. 15 minutes. This will just take a second to set all this up and you'll see how it works. So just bear with me for a minute here. Okay, let me look through here, make sure I got everything accounted for. I think I do. Okay, so basically what I'm telling it, we got 4 trucks. These are the orders. There they are. These are the roads we need them to treat. We want the tandem trucks doing the major A1 route here, as well as possibly some other A routes. And we want the single axle trucks doing the smaller C routes and possibly some others too, depending on what the most efficient solution is. So once I got all that, then I'm going to tell it to solve. And this may take, well, what did we do here? I forgot to set the parameters in here. Time and distance. There we go. Now, once you click solve, depending on how fast your computer is, how complex the program is, how many points you're trying to solve for, how many trucks you have trying to solve them. Basically, the more complexity you add to it, then the longer it takes for this to solve. I think when I did this yesterday, it took it about 60 seconds to solve. We'll see if it makes it that fast again. Obviously, I'm working at home. I'm working on a laptop here. This computer is a little bit slower than the one I have in my office when I'm at work, which has been a while since I've been there. But when I'm there, that one goes a lot faster, which will probably take about 5 seconds. And we've had some where we set it up for the whole, like a whole district, which may be 9, 10 counties, something like that, until it's solved. And basically, we would set it up to start running at the end of the day, say at like 4:30, click solve, and hopefully by the morning when you came back in, it would be finished. We got some results here. Let's see how we did. So what I'm going to do is right now it has all of the routes right here. It's just showing them all as green. So I'm going to break that up so we can see them individually a little bit better. Okay, you start seeing the lines showing up here. And then you can also do the same for this one. It can get a little difficult if you're just looking at lines, because sometimes it'll show, you know, maybe a truck had to drive across a line or down a road to get to where it needed to be, but it wasn't treating. But if that's the way it's drawing it, then it's going to be hard to see. And I'm going to add these to correspond. No, that's not what I want. There we go. Okay, so the single axle one is sort of that bluish color, so I'll make that one bluish to correspond. This one is sort of a maroon color, like that. Third one is a green, and then the fourth one is, where is it, purple. Okay, you can kind of start to see now. It starts to show up a little bit better. So if you look, just look at the dots, okay? You see you got all these maroon dots up here. This means it's sending this truck to get all these roads up here. It's also sending them down here to get these, and now it's coming down here. Sending the purple one out here to get this road, and then this road, and this road. It's kind of jumping all over the place. So the green's coming up down here and then over here. So you see it's getting a little jumbled. And that's kind of what we found with this. When I mentioned earlier, it's an iterative process. This would be the first iteration, and you'd say, man, that looks pretty complicated. That looks like something, not sure I want to give that to the truck drivers. They might say, this is garbage. I usually say throughout this anecdote, this actually, I mentioned we have truck drivers on our study advisory committee. When we were first doing this and we just piloting this methodology, and we showed them the routes for, I think it might have been Bourbon County, and it was, just chaos on the map. And the truck driver, he looked at the map and he said, if I came into work and you handed me this, I'd just throw it down and quit. I ain't doing this. So that was kind of a, it's actually very good feedback for us, because it's like, this is really important that you have to deliver something meaningful. I don't care what the most mathematically sound or efficient way is. You got to have something that's also realistic as well.
Right, because you can see at the top of the page, there's a purple at the very top, and then everything else there's south of that.
Oh yeah, there's purple in there.
Mm.
Yeah, I don't even know why you can see purple on the line. I don't even know why purple drove up there. It doesn't really make sense. But say this were the 10th or 12th iteration, we had it looking good. If that were the case, then you can come down here and you can kind of see. So we have tandem 1, tandem 2, single axle 1, single axle 2. And this kind of gives you the details on the route. You come all the way down here to the end. Renewal service time, that means that these two trucks went back and there was 15 for each, so they each refilled once. You can see the count for 15 minutes. You can see they all started at 8 a.m. and then you can see the different times they finished: 11:45, 12:17, 2 p.m., 2:45, 2:49. And you can also see, should be on here, where is it? The total amount of salt that they dropped. I'm trying to find that. Where is it? Oh, maybe I didn't set it to, well, anyway, you can set it to do that. That looks like I may not have done that. Okay, well, anyway, I just wanted to run through this. Oh, wow, I didn't realize this took that long. It's already 9:47. All right, I'm gonna have to do some speeding up here to get through the rest of this. Okay, that's okay. So the initial results based off that, we initially did District 7, which is centered on Lexington. You can see the current routes they were using, the modeled routes, the difference. These are minutes, I believe. Minutes to treat each of the routes, and then the percent improvement. So we had about 8.4% improvement.
Hey, Ben, can you make that full screen so we can see the numbers? Somebody may be working off their phone or small. There you go. Thank you.
So it was about 8.4% improvement. But again, we were kind of delivering results there that they weren't entirely happy with. It was like, okay, you're showing improvement, but this isn't necessarily going to help us because it's too complicated. So that's what I kind of talked about here, the routing issues. We wanted something more realistic. And we need to reduce the complexity as much as possible. Oh yeah, I do have to say, throw down the map and quit. So this was one of those examples. It looks like it was Anderson County, and we said, hey, does this make sense? And you can see the multicolor on the roads. Those are different trucks at different times going down those roads. It's just a jumbled mess. It was no good. So to fix that, we kind of came up with this concept of route trees, which is a similar strategy to what was currently used. So what you imagine here is, if you think about the trunk of a tree, say this is the road network, and this is the salt barn down here. And then as you spread out, right, you get these major branches here. These are the A routes. And you're going to send one truck down this A route, one truck down this A route, one truck down this A route. And then branching off those, you got these B routes, which are bigger routes. And so the truck that went down here, it's going to get that A route plus these B routes. And then the little ones are the C routes. And you're basically going to kind of put these trucks into zones centered on each of these major branches of the truck. So doing this, it's efficient, right? Because you're keeping the truck in the zone. That means they're not driving down roads they're not treating. The drivers get to become very familiar with the areas that they're treating. And it also makes it easier for drivers to deal with the complexities of an actual winter storm, right? Because we say non-typical winter storm, and I put that in parentheses because there's no such thing as a typical winter storm, right? We were charged to, what would it look like? What's the most efficient way to do it during a typical winter storm, which is about 1 to 2 inches of snow? Well, every storm is different depending on how much snow there is, how fast the snow is coming down, what the wind speed is, what the temperature is, how long the duration of it is. Was it just one county? Was it just one part of one county? Well, there's a lot of complexity that actually comes into an actual storm, and building in some, anytime you can make it easier to deal with that complexity is going to improve the situation. Okay, so once we got this, we delivered some results for Clark and Montgomery County, and also 2 counties. I think it was Grant and Pendleton County in District 6, and there was a lot of support for the results we're producing, so we decided to go ahead and go statewide with it. And so just real quick, the methodology, there were 5 steps in the way we do this. We get all the data from KYTC regarding the fleet and the roads and the priority routes. We develop our preliminary route optimizations just off the data. And then we would travel to the district and we would meet with the district officials, and they would bring in people from all over the counties to come in, the people who know the roads the best. And we would say, hey, here's what we got. What makes sense? What doesn't make sense? What do we need to improve? And we typically do those like 1.5 to 2 hour meetings and just go through a bunch of maps, and they kind of, I told them, this is your chance to throw darts at our results and tell us what we need to fix. And so then we'd come back, we'd take all their comments, and we would revise the routes to accommodate all their suggestions, and then we would deliver the revised routes. And if we still needed more edits, then we would set up a conference call at that point. So we did that with all 12 districts in Kentucky. So we delivered routes for all 120 counties in Kentucky. This is an example here. This is Montgomery County. If this is what our results, the final product would look like. So you see here the different color, we got a green tandem doing these up here. We got a single axle doing these. You can kind of see how it all lays out. And then over here, you can see how it works, how it breaks down amount of time on A routes, B routes, C routes, interstates, the total amount of salt used, and the total number of lane miles. And if you had 4 trucks, we would try to balance out the salt used in the lane miles as much as possible across the 4 trucks, so that you've got 4 people out there working the routes. They're all working about the same amount. I think I put a bunch of slides in here just showing you Montgomery, but we can go through it quickly. That's the whole county. And then some of the districts also want us to provide turn-by-turn directions for the truck drivers. What do they need to be going? So we put these together too. This is our first pass. They need to get to A routes plus that C route, A routes plus that C route, A routes plus that C route, A routes plus that C route. Because remember, the A routes are every 2 hours. So the first 2 hours will be getting it plus 1 C route, and then adding another C route the next time, then another C route the next time. And all that would take about 8 hours to do all that. That's the case for each of these. Okay, so initially we demonstrated success by the amount of time reduced, but as we went through this and we started learning more, we came to discover that a more useful metric for success was to look at KYTC's reliance on the contract trucks. I mentioned those earlier. They had initially over 400 contract trucks, and those are quite expensive. I think it's $25,000 per year per contract truck plus labor. So anytime you can reduce the reliance on contract trucks, you're saving the cabinet a whole lot of money. So that became something we really started focusing on, was the potential to eliminate contract truck routes. The schedule of the project, we started in 2016, developing the methodology, revising the methodology, implementing it for just a few counties, like I mentioned, and then by 2018, we were going statewide. And in December of last year, we turned in the final results for the final counties. I think we did District 1 last, which is out Paducah, far western Kentucky. So these are the results here, each of the districts, 1 through 12 here. The main thing I want to show you is down here in the very bottom here. Initially, there were 414 contract trucks. Based off our model, we suggested you could reduce it to 290. So that would be a reduction of 124 contract truck routes. And remember, that's 25,000 per year per truck. So that adds up quite a bit. In total, we did 882 routes across all of the 120 counties. So some of the accomplishments, the main thing really, like I said, if you add up, if you do the math, it's over 3.1 million potential savings for the cabinet if you implement these routes the way we suggested them. I would say it's not as simple as just, okay, we're doing this. It gets a little more complicated in actuality. You know, some counties are more able to implement them. And then the last thing, just to give ourselves a pat on the back, some of the presentations we gave, a couple publications we had. And the main thing was in 2018, we received the AASHTO High Value Research Award. That's the American Association of State Highway Transportation Officials. So we were very proud of that for this research.